All right, this is lesson 5.5. You will learn how to graph linear equations using the intercepts. That's the x-intercept and the y-intercept. In other words, the places where the line crosses the x-axis and the y-axis. And you also learn how to write linear equations in standard form. So we'll do this review real quick. You can pause and try it first if you want. Check back with the answers. One thing, make sure you take note of the vocabulary that standard form means an equation written like this. So here's an example, 3x plus 4y equals 10. That's written in standard form. All right. One thing that's really good about standard form is you're able to find 2 points really quickly, and that's the 2 points on the x and y axis. Let me give you an example here. Let's say that that's my y-axis and that's my x-axis, and this equation, when graphed, looks something like that. Crosses the y-axis and crosses the x-axis. At a certain point, where it crosses the y-axis, that's called the y-intercept. And where it crosses the x-axis, that's called the x-intercept. Now, one thing we know about the y-intercept is it's a point where the value of x is 0, and then there's some y value. And the x-intercept is a point where the value of y is 0, and there's some x value. So we know that part of those points is the number 0, depending on which intercept you're talking about. So when I want to find the x-intercept, I want y to be 0. And when I find the y-intercept, I want x to be 0. So if I have an equation, if I want the x-intercept, I can just substitute 0 in for y. So right there in the equation, I can put 0. So I get this equation, 2x plus 6 times 0 is equal to 18. Well, that simplifies to 2x plus 0 equals 18, and 2x plus 0 is just 2x equals 18. So x is equal to 9. So I just found out that this point where this line is going to cross is 9 on the x-axis. The x-intercept is 9. And to find the y-intercept, it's similar. It's just that I let x equal 0, so I'm going to substitute 0 for x in the equation and solve it for y. 2 times 0 is 0. 0 plus 6y is 6y. Divide both sides by 6, and I get y is equal to 3. So that means that this point is 0, 3, and this point is 9, 0. All right, go ahead, you try it. Check back for the answer. All right, so if it's written in standard form, it's pretty easy to graph because there's 2 really easy points to find, the x-intercept y-intercept. So we're going to find those. Remember, to find the x-intercept, we let y equal 0. And to find the y-intercept, we let x equal 0. So if I let y equal 0, then I'm solving this equation. 4 times x minus 3 times 0 equals 12. So 4 times x minus 0 is equal to 12. So 4 times x is equal to 12. So x is equal to 3. So that's my x-intercept. And my y-intercept, I'm going to let x equal 0. So I'm going to do 4 times 0 minus 3 times y is equal to 12. And 0 minus 3y is equal to negative 3y. And divide both sides by negative 3, and I get y is equal to 12 divided by negative 3, which is negative 4. Now, I messed up here. This graph doesn't really work very well, so I'm going to get rid of those numbers. Put in axis right here, y-axis, and x-axis right there. And then I can graph my x-intercept right here. X is equal to 3. That means when y is 0, x is 3. That's that point. And then y equals negative 4. When x is 0, y is negative 4. That's that point. And I can draw a line through those points. And there's my graph. That is the graph of 4x minus 3y equals 12. Go ahead and you try that. Check back for the answers. All right, what is the graph of each equation here? Well, if x is equal to negative 1, let's think of some points that we can graph where x is equal to negative 1. So these are just random points, but if x is negative 1 and y is negative 2, that's one point where x is equal to negative 1. Negative 1, 0 is a point, negative 1, 5. Let's do a positive number. Positive 5. So if I graph those, negative 1, negative 2, that's there. Negative 1, 0 is there. Negative 1, 5 is there. And if I draw a line through those points, I get a line that looks like that. And that's what the graph of x equals negative 1 looks like. Similarly, to find some points where y is equal to 4, let's just think of some values, like if x is negative 2 and y is 4, x is 0 and y is 4, if x is 3 and y is 4, those are points where y is equal to 4. So negative 2, 4, that's right there. 0, 4 is there. 3, 4 is there. If I draw a line through all the points where y is equal to 4, I get this line. So, an equation like this, where y is equal to something, is a horizontal line. An equation like this, where x is equal to something, is a vertical line. Go ahead and try that. All right. Putting an equation in standard form using integers. Standard form looks like this, where you have something times x plus something times y equals constant. It says we want to use integers, so that means that my a and my b and my c, I want all those to be integers. Sorry about the bell there. So I need to change some things to put it into that form. One thing I need to change is I need the x and the y to both be on the same side. In this case, on the left side is equal. To do that, I'm going to add 3/5 x to both sides. because adding 3/5 x over here will make that equal to 0. So now I have 3/5 x plus y is equal to 4. Now it's in this form, ax plus by. A in this case is 3/5, b is 1y, and c is 4. The problem is we wanted it in integers, so we want to do something to get rid of this 5 there. An integer is not a fraction. So, and one way we can do that, if I multiply by the denominator, 5, if I multiply both sides by 5, when I multiply 5 times 3/5, using the distributive property, I get 3x. 5 times y is 5y, and 4 times 5 is 20. Now, a is 3, b is 5, and c is 20. They're all integers, and this is in standard form. So, I'll let you try that. First thing I would do to get this in standard form is try and get rid of that fraction. To do that, multiply both sides by -3. So then we get, multiply by -3. When I do that, I end up with -3y plus 6 is equal to, -3 times -1/3 is 1, and 1 times any number is just a number. Now, if I subtract x from both sides, or add -x to both sides, I get -x plus -3y plus 6 is equal to 6. And if I subtract 6 from both sides, I end up with -x plus -3y equals 0. And -x is the same as -1x. So those are integers. -1x plus -3y equals to 0. All right, one more problem. A festival sells ride tickets for 50 cents each and game tickets for 20 cents each. You have $5 to spend on tickets at the festival. Write and graph the equation that describes the items you can purchase. What are 3 combinations of game ride tickets? So we're going to use a graph to help us do this. And I'm going to set up some variables here. I'm running out of time, so I need to pause it, and I'll explain it after I do that. All right, here's what we have. So if we let x equal the number of ride tickets and y equal the number of game tickets, then 50 times x is how much I spent on rides in cents, and 20y is how much I spent on games in cents. And so the total spent is what I get when I add those two together, and that's equal to $5 or 500 cents. So my equation is 50x plus 20y equals 500. Now, to graph that, I want to find the intercepts. Now, the x-intercept is when y is 0. In other words, if I spend nothing on games, how much can I spend? How many tickets do I get for rides alone? And that would be 500 divided by 50, which is 10. My x-intercept is 10. My y-intercept is, if I spent nothing on rides and I spent all my money on games, so I took all 500 cents and divided by 20 cents, and that would give me 25 of those. So now to graph it, I have the 2 intercepts. Let me pause so I can get a graph ready. All right, so here's my graph. My x-intercept is 10, my y-intercept is 25. And if I draw a line there, any place where that line crosses a value on the y-axis is a possible number of that I could use at the festival. So look for places where they cross. Any place on that line.